Okay, good morning class. So today we're looking at geometry. We're looking at the similarity in particular. And we're on page 31. Okay. We're looking at E now. So we are told the intra-angle, in the diagram, CE, the length of CE is twice AE. So what I'm going to do is I'm going to write that on there. CE is twice AE. So there's a relationship already existing between that line and this line. Can you see? Then we are told that BE is half DE. Okay? But B is known. B is 3. So that means to say that if BE is equal to half DE, that is given, then that means to say that 3 is equal to half DE. Not so? Is anybody confused? You see that BE is already marked as 3. This was not marked. Wait, it was marked, sorry. So instead of writing 2, AE, I could have worked out the value there already. Okay, I should have. But I didn't see the 4 for some reason. Okay, so what do? I divide by half both sides. So DE is equal to, what is 3 divided by half? 1,5. 6. There was 6 halves in 3. That's going to be 6 centimeters. So DE is 6. Right, so with the other one we see that EC is equal to 2AE. Where do we get that from? It's given. So A is what? 4. So EC is going to be 8, or 2 times 4, which is 8. You guys understand? Then we're told that AB over DC is equal to 1 over 2. Where do we get this from? It's given to us. Alright, so there we link that. What was the question? Coming back here, the question was, for those of you who don't know, the question was, show that the following triangles are similar. So how do we prove similarity? One of two cases, how do we prove it? We prove that the angles are equiangular, or we prove that the sides are in proportion. Okay. So already we know that we already got that ratio. Not so. So we can go with this ratio here. Not so. Because if you go with remember this is a half. So 4 over 6 is 2 over 3. Can you see that? And 3 over 8 is 3 over 8. We want to end up with a half if it's similar. Can you see that, people? So which other ratio are we going to go with here? We're going to say that BE over ED. So what's BE? The length of BE? 3 over 6, which is? Oh. So there we got that link as well. And then the next one? AE over EC is equal to 4 over 8, which is equal to? So hang on. Hang on. Stuff is coming together now. No? What do we say? Since, yes. Since AB over DC is equal to BE over ED equals AE over EC equals oh. Therefore, triangle ABC, ABE is similar to triangle. So if we start at A, BE, then remember I'm using that 3, so I must pick up the 6 here, not so. So it's going to be C, E, D. If I go DC, E, then I'm not picking up the 6. You see that, people? So it's C, D, E. And what the count is this? That they are similar because it is angle. Something like this probably worth 6 marks. Okay. Yes. Sorry? Yes, absolutely. You see, I would have lost one of the 6 marks. Okay. I would have lost the pauper, back of the pauper, no? Sides in. Sides in proportion. Thank you, Mike. Right. Easy enough? Right, let's go with F. We're still on page 31, eh? Must prove that triangle ABD is similar to triangle BCD. Right, where do we start? In triangle ABD and triangle BCD. Right. So we got A, B, D, which is a triangle, and B, C, just triangle. What can we prove so far? Oh, okay. Firstly, to prove similarity, we're going to either prove that the two triangles are equiangular, we're going to prove that the sides are in proportion. Can I go with sides in proportion here? Why not? They don't have sides there. Not so. But what do we have? We have angles. So we know that B2 is equal to A. Why? Given. Another angle we need. B1 is equal to angle. Why? Where is it given? It's given to you. Not given on the diagram. Yes, Michael? Angle. The whole angle B. But am I going with the whole triangle here? No, I'm going with A, BD, and BCD. That is the one triangle, and this is the other triangle. Yes, Michael? B2, yes? Why? B2 is equal to half of angle. But what's your reason? What's your geometry reason for that? Your theorem. What theorem are you using? Anyone else? Yes, Michael? These are angles on a straight line, yes? Then angle D2 is 90 and D1 is also 90. So the two angles are equal. Angles on a straight line. Can you see that, people? So there we have 1, 2, then automatically the third one will be equal. Right, you guys understand? So let's go. So we are saying firstly that angle A is equal to angle B2. Why? Given. Then she said that angle D1 is equal to 180 minus 90. Reason? Straight line. So D1 is of course equal to 90 degrees. So there's also 90 now. Therefore, D2 is equal to D1, which is equal to 90 degrees. Okay? Next one. So we got this angle, we got that angle. So we can now then just say that B1, angle B1 has to be equal to angle C. Why is angle B1 equal to C? Because it's the third angle of. Is that enough to conclude similarity? Yes. So therefore, triangle ABD is similar to triangle. So let's go. A corresponded with B. Can you see that? Then B corresponded with C. And then D corresponded with D. What's the case of similarity here? Angle, angle. Okay. Any confusion here? 5 marks and something. Okay. Still on the same page? Right. So here we are told the following pair of triangles are similar. So here we are told the triangles are similar. Okay? Calculate the value of x and y in each case. Okay, so what can we say? The triangle PQR is similar to triangle DEF. And where are we getting that from? It's given. Nobody, the first part of the question would be prove that the two triangles are similar, and then they ask you to work out the sides. Okay? But here they're telling us that they are similar. The problem with this is because I could have said this PQR is similar to triangle DEF, then somebody could have said PQR is similar to triangle FDE. You see the problem that's going to arise here. They just tell you it's similar. Okay, but we're not rebellious, really. We just go with the normal, no? We don't want to be difficult. Right? But in essence, they have to either give it to us, the order, or that we must prove the order. Okay, that's how it's normally done. Okay, but let's play along. Let's act dumb and play along. Okay. So what do we say? If we're working out lengths, what do we say? PQ over DE. So PQ over DE must be equal to QR over ED. EF, sorry, which is equal to P R over here. What's your reason here? Sides are in proportion, or you can say the triangle PQR is similar to triangle DEF. So what can I do with that now? PQ is what? What's the length of PQ? 9 over DE 3. Now there's your known ratio. QR, sorry, 9 over if this is 3. Okay, which is equal to PR 6 over 1, which is DF. Okay, do you guys understand? So, if I was them, I would have probably put an X here or Y, X there, whatever. Okay, so normally you have one ratio and you must solve two parts. Okay, but okay, that's how they did it. So, You all agree I'm going to go with that ratio then. You could either go with 9 over 3 and 6 over y, which is the same as 9 over 3 and 6 over y. Can you see that, people? So how do I solve y here? Cross multiply. So 9 times y is 9y, 6 times 3 is 18. So I divide by 9 both sides. So y is equal to 2 centimeters. Alright. Any issues there? No? Next page? Okay, that's on page 32 now. B. Okay, yeah, they were nice. They told us that those triangles are similar. See how nice they are now? That's probably no. No, they did. Okay. So what do we say? If triangle PQR is similar to triangle TSR, what can we then say? PQ over TS is equal to QR over SR equals PR over PR. Why? Why is that the case? Because triangle PQR is similar to triangle TSR. You all agree with that? So what can I say now? What's the length of PR? PQ, sorry. PQ 16 over TS 10 equal QR is X over SR 15, which is equal to PR unknown over TR unknown. But do I need this? No. That's all I need. Why? Because the question says if the triangles are similar, solve for X and Y. So how do I solve for X here? Let's multiply. So it's going to be 16 times 15 is equal to 10 times X, which is 10. So I divide both sides by 10. You all agree with that? So X is equal to, now 5 goes into 15 thrice, and 5 goes into 10 twice. 2 goes into once, 2 goes into 16 4 times. 2 goes 8. 3 times 8 is 24. Okay, or you could have just said 16 times 15 divided by 10 gives you 24. Okay. Should be coming but easier now, isn't it? Yes.
So can you simplify the 16 over 10 before you?
Yes, before you go into the step, you could have said it's going to be 8 over 5. Anybody else? Alright. Let's go with C. Yeah, they're nice. They're giving us the similar triangles, no? So here we are told that BDZ is similar to triangle XYZ. So where do we start? We say that DB over XY is equal to BZ over YZ, which is equal to DZ over XZ. What's your reason here? Triangle DBZ is similar to triangle XYZ. So what's the length of BZ? BZ or DB. Sorry, DB is Y. Or is that why you're saying that? Okay. Over xy, 12 must be equal to bz x over yz 9 equals dz 10 over xz 10 plus 5, which is 50. So there's my known ratio. Can you see that? So when I work with this, I'm going to block those two together. Okay, so what do I do? How do I solve for x? Cross multiply. So x times 15 is 15x is equal to 9 times 10 is 9 times 10 or 90. How do I get x on its own? Divide by 15 both sides. Not so. It cancels. So x equal to 3 goes into 9 thrice, 3 goes into 5, 15 5 times. 5 into 5 once, 5 into 10 twice. 2 times 3 is 6. Or for those of you can see that is going to be 2 over 3, so that's going to be 6 over 9. You just say x equal to 6. Well, otherwise, we can block those two together. So you say y over 12 is equal to 10 over 15. Cross multiply. So it's going to be 15y is equal to 120. Divide by 15 both sides. So we'll divide 15 both sides. So it's going to be 15y is equal to 120 divided by 15. So it's 120 divided by 15. Here's an answer of 8. So y is equal to 8 centimeters. Well, there's no unit, so you just say unit, so you can leave it blank. Okay. People, is there any confusion here? Huh? Is this also part of page 32?
Yes.
How many is left on page 32? The last one. Okay, so let's just wrap this up quickly. Instead of doing it on a different video. We say those two triangles are similar. So where do we start? We say that PQ over PD is equal to QR over DE equals PR over PE. Why? Because triangle PQR is similar to triangle PDE. So PQ, there's a Q here. So PQ
Good morning,
is going to
may I have
be
your attention please?
4 plus
Zara
6
Moses, can you please report to the
over
office?
PD, which is
Zara
4,
Moses, please
equals
report
QR.
to the office.
QR is 10 over DE, which is 5. PR is y plus 3 over PE, which is 1. You see that, people? So what we do is we block that off. There's your known ratio. And cross multiply. So it's 4 plus x times 5 is equal to 4 times 10, which is 40. Divided by 5 both sides. So 4 plus x equal to 8. X is equal to 4. We can test it. 4 plus 4 is 8. 8 divided by 4 is 2. 10 divided by 5 is 2. Okay? Otherwise, we block these two off. Cross multiply. So it's going to be 10y is equal to 5 into y plus 3. Divided by 5 both sides. So 2y is equal to, that cancels. That cancels, leaves you y plus 3. So you get over the equal sign. The 2y plus y minus y is y. So y is equal to 3. And we can test it. What's 3 plus 3? 6. And 6 over 3 is 2. As 10 over 5 is also 2. Okay, so that brings us to the end of page 32. Is that correct? Right. So in our next lesson we will probably conclude the similarity. Okay.